So our very first step that we talked about is I need to find a greatest common factor of our first two coefficients, so our A and our B. In this case, the greatest common factor between A and B is 3. So I take the 3 out. When I divide these two terms by 3, I end up with x minus 4x, then outside the brackets plus 17. So our very first step was to find the greatest common factor of our first two coefficients, bring it outside. The next step, I take my coefficient of the second term, so our negative 4. I take this negative 4. I need to divide it by 2 and square it. So when I divide negative 4 by 2, I get negative 2. And when I square that, I get 4. So I've now divided that term by 2 and squared it. I get 4. So what I need to put into the brackets again is I now have to add and subtract by this 4 inside the bracket. So I positive 4, negative 4, and I bring down the 17. Again, remember, this positive and negative 4, they're just creating a 0. So technically, they don't change the equation. But they're helping us to create a perfect square. That's the whole goal of this. So once I've done that, we know our next step is I need to take this negative 4 outside of the brackets. When I go to do that, I need to take that negative 4 and multiply it by the term that is in front of our brackets. So I take my negative 4 times my positive 3. I end up with negative 12. So in my next line, I have 3x squared minus 4x. I keep the positive 4. And when I bring the negative 4 outside, we discovered it becomes negative 12 because we had to multiply it by the 3. So I have negative 12 plus 17. Now, I'm just going to simplify the end part of this. Negative 12 plus 17 is positive 5. And if we take a look, we've once again created a perfect square. I can find the square root of this, the square root of our last term. So square root of x squared is x. Square root of 4 is 2. And because this is a negative sign, we bring the negative down. So I'm just going to talk you through that one more time. So square root of x squared is just x. Square root of 4 is just 2. And because there is a negative term in front of our middle coefficient, we put a negative down in our next bracket. So I have 3. My first term, because we found the square root, was going to be an x. My last term was going to be a 2 because we found the square root of that. And because that's a negative, we put a negative inside. Put a square at the top. That's it. That is our final answer. So in case you're confused about that step there, I took x squared minus 4x plus 4, and I factored it quickly. So factors of the first term, 1 and 1. Factors of the last, 1 and 4, 2 and 2. Okay? I know they have to add together to get our negative 4. By looking at this, I can do in my head, I know that these are the two columns we're going to end up working with. 1 times 2 is 2. 1 times 2 is 2. And to become negative 4, they both have to be negative. So both of those will be negative. When I go to write this at the end, my first terms are going to be an x and an x. My last terms, and because they're the exact same, it doesn't matter which bracket I write them in, are both going to be negative 2. So to write this a little simpler, instead of having 2 brackets and write it as 1, we just write x minus 2 squared. So really what I did is all of these steps in my head. I knew I created a perfect square by doing this, so I know that I can do that quickly in my head and get this as our answer. Your homework for tonight is page 214. 5A to C, we've already done A, so it's just B and C. 6A to E in question 8. All right, this is question 12 from last night, so this is lesson 4.1, and it's on your text page 205. The question gives us two zeros. Let's get our whole graph in here. It gives us 2 points for zeros, 1 and -3. So our -3, that's one of our x-intercepts. Our other x-intercept is going to be 1. They've also given us a point of 2 and 10. So they've given us 3 points. We need to make some parabola, and the question says to put it in vertex form. So by looking at this quickly, I already know that this is going to have to be a parabola that opens upwards. It'll have to open upwards for sure, because this point is to the right of one of our x-intercepts. So I know it's going to be positive. All right, that's one step. Secondly, I have my two zeros. I can find out what the axis of symmetry is by using those two zeros. The axis of symmetry is going to be right in between the two of them. Okay, so I take my 1 plus -3. Guys, remember, we add them together and divide by 2 to find our axis of symmetry. This becomes -2 over 2. Our axis of symmetry is at -1. So that means I can draw a line on my -1, straight up and straight down. This is going to be our axis of symmetry. Very nice. We've gotten that. So we know that our vertex, one of the points of the vertex is going to be -1. That'll be our x. We're just going to be looking for our y now. Now, one of the things we can do is this is a step. We know there's 2 steps from the vertex over to our axis of symmetry. There's 2 steps both ways, in fact. Now, if you guys remember when we draw parabolas, we don't know, like we said, where the y is going to be. The y is going to be somewhere along this line. We're not sure where it is. But we know that we go from wherever the vertex is, 2 steps over, and some amount up. We also went 2 steps over and some amount up. Right now we're trying to find for the y and a. Okay? So we do have a point here. We know that we go over 1 and up 10. Okay? We need to compare this to our original, oops, I didn't even draw a line, our original type of parabola. So I'm going to make sense of this with numbers a little. If you guys remember when we go to draw a normal parabola, which has no increasing by a certain factor, our parabola is just x squared, y equals x squared. And what happens is when we start our vertex, so when we go to draw our normal parabola, if you guys remember from a while back, good in blue, our vertex would start here. We go over 1 and up 1. Over 1, up 1. Then we go over 2. How many do we go up? 4. We square it. Over 2, up 4. When we go over 3, we go up 9, which doesn't quite show up on this graph. I should show you a better one. This is our regular parabola. Okay? So when we go over here, and we go to take a look, we do have a point. We know, once again, our axis of symmetry is the x point of our vertex. So it's going to be somewhere in here. We just don't know quite where it is yet. And we know that that vertex is going over 3 spots, and it goes up to here. We do have one of the coordinates. Okay? The only one we have a difference between is this x-intercept and this point here. We know that we go over 1 and up 10. And this is a difference of 2 here. So this part gets a little confusing. So I'm going to try to redraw it on another graph down there. So we know that the third movement, you know what? All right. So I've redrawn this a little here. I'm going to explain what I've drawn. So our blue graph, let's redo this part here. Our blue graph is a normal parabola. And on our blue graph, when we go from the second point over to the third, So, the only movement we know about on the graph we drew above is going from our second. What the heck's going on there? I don't know what happened there. Oh well. The only movement we know about is, remember, our vertex is here. So this is 1, 2. So this is 2 points over on the from the vertex. The only movement we know about is going from 2 to the third. So we go over 1 and we went up 10. On a normal graph, when we go from our second to our third point, we go over 1 and we only go up 4. On theirs, they're going up 10. So that'd be going from 4 to like 14, something like that. We'll do that in red. Okay? So what that means is we have to figure out what the difference is from going from 4 to 10. What do I have to multiply 4 by? That's annoying. I can't figure that. It's a movement of 4 to a movement of 10. So essentially, it's 4x is equal to 10. I figure out what x is. When I divide both sides by 4, it turns out x is 2.5. What I just solved for is not an x, but an a coordinate. That's the factor of the stretch. We figured out that this, when we put this in vertex form, our a is going to be 2.5. So, when I'm going to rewrite this in vertex form, we have our a is going to be 2.5, x minus, we know that our h is -1, so in this case what's going to happen, when we go to simplify it, we have x plus 1 squared plus k. This equals y. So, what I just figured out, guys, is I discovered what my a coordinate was. It was 2.5. The way I did that was figuring out how much a normal parabola goes up by to what our new parabola went up by. Normally it would go up by 4 in that movement from the second to the third point. In our new parabola, we went up 10 from our second to our third point. So I have to figure out what kind of factor they multiplied by. I know that to go from 4 to 10, I would have to multiply by 2.5. So my factor is 2.5, or my a in our vertex form. We also discovered the axis of symmetry up here to be -1. So I knew that the vertex, when I go to write in vertex form, our h would become +1. Now that I have an a and an h, and I do have a point, they gave us a point earlier, it was 2 and 10, I can plug those in for the x and y coordinates to solve for k. This is a very in-depth question. So our y, we would substitute 10 in for. Our x, we'd substitute 2 in for. And we isolate and try to solve for k. Uh, 9 times 2.5 is going to be 22.5. Is that right? Okay. And subtract 22.5 equals k. -12.5 is our k. So in vertex form, I know this is a very in-depth question, and I realize it's going to be so hard. Y is equal to 2.5 x plus 1 squared minus 12.5. That would be our equation in vertex form. You won't have something like that on the test. But if you're able to get that, way to go. Very impressive.